Okay, what's up guys? So today I'll be talking about chemical equations, okay? Basically your foundation, okay? For many upper sec students, you should be okay with this already, but I'm just explaining this to help you with your basic stuff. Okay, some of you can't balance equations, this is the chapter for you. Okay, so equations are broken down into mainly three different things. You have your word equation, which is something you learn in sec 2, and then you have chemical equations, which you learn in upper sec, and then ionic equations, which come right after chemical equations. Now, chemical equations and ionic equations will require you to write your state symbols, which is why I added there on top, as you can see here. Okay, so let's start with the general equations. So there are mainly 4 general equations you'll be learning, but I'm talking about 3 of them here. Okay, metal plus acid, which gives you salt and hydrogen gas. Base plus acid giving you salt and water. Students will know this as neutralization. So if you still don't know what a base is a metal oxide or a metal hydroxide, okay, as I've written here. And then the last one we'll be talking about for today is carbonate. So carbonate plus acid gives you salt, water, and carbon dioxide. Okay, basically you see these two variations of the general equation is just an extension of your metal plus acid. Okay, you see that your metal will produce a hydrogen gas. Okay, a base is a metal oxide, so whatever stuff you have remaining here will be hydrogen plus the oxide from the base, which gives you water. That's why base plus acid gives you salt and water, but there are more reasons. And then carbonate. A carbonate is just a base plus carbon dioxide. As you can see, a carbonate is CO3, right? So CO3 is basically an oxide ion, which is O, and carbon dioxide, which is CO2. So O plus CO2 gives you CO3, right? So you see that this CO2 will just travel to the other side, and then you have a standard base plus acid equals salt and water. Now don't worry if that was too confusing for you, okay, I'll be talking more about that later. Okay, so we will start with the acids. Okay, so there are 3 main types of acids that we'll be looking at. Okay, basically for your entire secondary school syllabus, you'll be looking at 3 different types of acids only. The first acid we're looking here is sulfuric acid, which is H2SO4. So an example of a reaction we have here is magnesium plus sulfuric acid, giving you magnesium sulfate and hydrogen gas. Okay, so you see that sulfuric acid is basically made up of the hydrogen cation and a sulfate anion. The sulfate anion will be combined with the metal, as you can see here, and then the hydrogen ion will be left alone, okay, which is most of the reactions that you see. Okay, all the reactions you see here are just an exchange of partners. Okay, so you can see magnesium stealing hydrogen's partner here. Yeah. Okay, it's important to understand that sulfate ion is of charge 2 minus as well. Okay, because you need to know the charge if you want to balance equations. How I like to remember charges is that I see H is always plus. So if there's a 2H, if here is 2 plus, then here should be what? Here should be 2 minus. Simple. Okay, the next 2 acids that we are having is nitric acid and hydrochloric acid. So for nitric acid is HNO3. Okay, so a typical reaction like that would be Mg plus 2HNO3. Don't bother about the 2 first, I'll explain. That is all part of the balancing. Okay, most importantly you need to understand is that the only thing you need to take away is that nitric acid produces an anion called the nitrate ion. The nitrate ion is of charge minus. Okay, this is important, I highlighted in red because this will be combining with your metal. Okay, it's important stuff. And then hydrochloric acid is pretty much the same thing. You need to understand that hydrochloric acid produces a chloride anion of charge minus because HCl. H is plus, Cl should be minus. Easy. Okay, and this would be the one that connects to the metal, as you can see here. Okay, so now I'll be talking about the different types of equations which you will see. mainly word equation, chemical equation, ionic equation for each different types of chemicals. So the first chemical reaction we see here is the metal plus acid. So the standard word equation would be, for example here, magnesium plus sulfuric acid, giving us magnesium sulfate and hydrogen gas. Okay, and then a chemical equation is basically the same thing but represented by chemical symbols, chemical formulas. Okay, so you see that H2SO4, okay, H2 is 2 plus, SO4 is 2 minus, right? So when they combine together, the anion will be transported to here, will combine with the metal. Okay, now if MgSO4 is 2 minus, you have to ensure that the cation is of charge 2 minus as well. Okay, and this chemical equation is balanced. Why? Because magnesium is in group 2. Now if a metal is in group 2, the charge will be 2 plus. Easy. Okay, if it's in group 1, the charge will be 1 plus or plus. And if it's in group 3 like aluminium, it will be 3 plus. Simple. And then the ionic equation is really simple. It's pretty much standard. Okay, so it depends on your type of metal plus hydrogen ions, giving you a metal ion plus hydrogen gas. Okay, so metal atom plus hydrogen ion equal metal ion plus hydrogen gas. Standard stuff. And then for the balancing, there's really only 3 steps. Okay, so an example of a reaction we have here is Mg plus HNO3, magnesium plus nitric acid. So step 1 is to identify the type of reaction. So how do I identify the type of reaction? You see here that the first reactant you see is magnesium, right? So magnesium is a metal because you can find it on the periodic table. So immediately think of the general equation, metal plus acid equals salt and hydrogen. And then you write a quick draft of the equation. Mg plus HNO3 is MgNO3 plus H2. Now this equation is not balanced or checked yet. Just know that this is this is like the first draft of the writing, okay, of your answer. And then what you need to do next is step 2, check the salt. Okay, check the salt. So how do I check the salt? You just check the charge of both reactants. So you know that Mg is in group 2, so the charge is 2 plus. NO3 is minus, okay? Remember that your nitrate ion is of charge 1 minus. So what you need to do is know that they are not balanced out, okay? Because your cation is 2 plus, anion is 1 minus. So you need to multiply your anion by 2. Okay, which gives you this MgNO3 2. Okay? And then your last step, after you balance the salt already, is to balance your equation. Okay, if your NO3 already times 2, then your HNO3 must also times 2, right? Your HNO3 cannot give birth to another NO3 ion, right? Doesn't make sense. So you need 2 HNO3 as you can see here. Okay, after this, your equation is balanced. Next, we talk about the neutralization reaction, which is base plus acid giving you salt and water. So I'll just quickly explain why is it called neutralization. Now we know that acids always have a pH of less than 7, right? Simple. And then a base, which is a metal oxide, always has a pH of more than 7. Okay, metallic oxides always have, most metallic oxides, if not amphoteric, will be basic. Okay, and then non-metal oxides will be acidic. So when you have an acid, which is a pH here, and then a base, which is a pH here, when you add them up together, they are going to come towards the center, and then they are going to meet in the middle to produce water, pure water. Okay, that's why it's called neutralization, because both chemicals are reaching pH 7, which is neutral. So we have standard equations, as you can see here, sodium hydroxide plus hydrochloric acid giving you sodium chloride plus water. Ionic equation for neutralization is standard as well. Your OH ion, which is hydroxide ion, the basic ion, plus the acidic ion, which is hydrogen ion, gives you water. Okay, it's standard. Okay, and then we look at the last type of equation here, which is carbonate plus acid, giving you salt, water, and carbon dioxide. So if you notice what I said earlier, a carbonate is basically just a base plus carbon dioxide, okay? Because you get a salt and water, which is stuff that a base produce, and then you get carbon dioxide, which is the extras. Okay, so your ionic equation is this. Basically, the carbonate plus the hydrogen ions will give you your metal ion. Basically, the electrons, this ionic equation tells you how the electrons are transferred. Okay, that's the simple way to say it. So equals to your metal ion plus water plus carbon dioxide. It is standard. Okay, standard. Carbonate and your metal ions are the only things that will change around. Okay, so I've prepared 5 questions for you guys to try. I hope you guys can try it and then maybe WhatsApp the group or something. Okay, if you have anything you are unsure of. Okay, so pretty much that's it for today's chapter. Okay, really simple chapter, basic stuff that you guys should already know. Okay, so in case you need, this is a quick summary of the chapter we've covered today. Acids, the 3 different types of acids, the anions produced by these 3 acids, and then we have ionic equations, which I believe you guys would require some help in. Okay, so these are the 3 standard templates for ionic equations. Metal, solid, metal plus hydrogen ions will give you a metal ion, okay, of whatever charge you want, plus hydrogen gas. Okay, so that's what I'm trying to write here. And then for neutralization, it is standard. Okay, it's always the same, it's fixed. And then for carbonate plus acid, okay, it's slightly more confusing because you have to write the carbonate and the metal of a certain charge. So these are the only 2 things that will be changing. Okay, so yeah, I hope this chapter helps you, and I'll see you in the next video.